Welcome to series of conceptual classes on organic chemistry. Today's class is class number 7 and it is on Amine and it is the last class. I have today divided the class into two parts. First part is relating to amazing concepts and trick, and second part is direct solution on textual conversion. So first of all, I want to give advice to some of the students, those who have just gone through my classes regularly. I request them to subscribe the class, don't miss the class. Those who have doesn't miss the class without any missing, if you have are continuously observing my class or following my class, they will find the class today's class most amazing. So you will yourself will find most amazing when you will find that you yourself can solve the problem. You can make the question, you can solve the question yourself. And this is all about the concept what I am talking. You will feel proud that you can do something yourself. And chemistry is fun. Chemistry is nothing but solving out the problem yourself. It is puzzle game, just like as a puzzle game. Just you follow what I see within a 5 or 6 minutes I will solve out a problem, then I will go to jump to the final part of solution of conversion of Amine chapter. Phthalic acid. You have got the reaction already. All you know, you yourself go on solving. I have randomly taken one example. Randomly. Give heat. Those who have gone through my class have got each things I have described in the chapters itself. Next, you do just give potassium hydroxide in aqueous. An alkyl halide. I will name the reaction, you will understand. I will give you the hints how I have done it randomly. Sodium hydroxide aqueous. Nitrous acid. oxidation, chlorine. I will explain it. Benzene, nitrating mixture, nitrobenzene, benzene diazonium chloride, cyanobenzene, acid hydrolysis. Everything is from your previous class. I am doing everything from the. I will go on solving. You just follow me. Letter U and bromine here. no space left, I can go on, continue this one. So what is the most interesting fact is that if you know the concept, you can go on doing randomly. You yourself make the question and you yourself go on solving the. This is the map. This is the conversion. This is what type the reaction I have involved. A lot of things here I am showing you. This is phthalic acid, reaction of ammonia, you know it, COOH4 on heating, water molecule goes out, and thelimite, Gabriel thelimite reaction is occurs KOH, NK, alkyl halide, primary amine, and then nitrous acid, alcohol. In my last class I have told what happens when alcohol reacts with nitrous acid, what happens when nitrous acid, I have shown it. Then this, and this part there, it is a bit tricky part, I will later on explain if I get times. It is haloform reaction, it is chloroform, again first reaction, very famous reaction was there, silver reaction with chloroform, silver dust, it gives ethane or acetylene is red hot iron passed, it is from first year. Again you get benzene, nitrogen mixes nitrobenzene, ferrous nitrobenzene is a reduction. In my last class I told benzene diazonium chloride, CN, last class Sandmeyer reaction I told, this is CN, last class I told CN on oxidation, complete oxidation, hydrolysis on acid gives carboxylic acid, on reduction CO group becomes CH2, PCl5, CH2Cl, oxidation, aldehyde, and it is again Kenisara reaction, self auto oxidation and reduction. This is oxidation part, this is reduction parts. When these parts again react with pseudolime, you are again getting benzene. This is Friedel cup reaction, gives toluene, again acidic mixtures, gives orthopara, para is the major, para position nitro, again bromine appears in ortho position, again reduction, FeHCl or TnHCl, anything, nitro group becomes NH2, again NH2, amine becomes benzene diazonium chloride, and H2PO3, then this group vanishes, this appears, on oxidation KNMN of CH3 becomes CW. All from the last class I have told that I have summarized the class and I have given each and everything. You've gone solving, you've gone again ammonia, give this, gone, you've gone, it is endless way. You will go, you will find the reaction endless way. You yourself can make and go on doing that. So you will find that all organic chemistry, all conversion, each and everything is in your hand. If you can only know, I always give preference that if you have the knowledge, if you have the concept on yourself, you can make the question yourselves and go on solving the question, and in this, whatever the way you get, you just use the reagent and go on solving the one. So my first part, this part, why I have shown this one, that it is not me, that you yourself can do this if you know the concept. This is the motivational part, that you are always afraid of the conversion and this and that. Today I have shown you that nothing is difficult if you have the knowledge on the reagent and the type of the reactions which involves out of the carboxylic acids. I have started and I have gone through amine and this and that. Except from some part of Pfizer, Kenisara and this and that, each are from the last part of the reactions, each and everything. Those who have just followed my class, these things they will find very easy, and they will find the organic chemistry is very interesting, and it is nothing but a fun. I think it is nothing but a fun. Now I am coming to the main part, that conversion. How you can assume that from which part to which part I will go. So in maximum of the student asks me what are the ways, whether we will make practice upon this, we will go on doing this and this. No, I never prefer these things, that you will go on writing the questions, conversion again and again, and you will keep it in mind, you can give the answer correctly in exam. No, there are some fundamental rules. Out of my experience, I will just give you some of the few facts, 2 or 3 facts, and out of this fact, I will start doing the conversion of textual conversion. Within 5 or 6 minutes, I will solve each and every one, every problem. If you know the facts first, first fact is that, first fact, just minutely follow and please patiently follow my class from first to last. I think for conversion you will be the king of conversion. First you see, whenever you find COOH group, we have one option. I will tell you what will you do. You will get amide. When you find CN, you have two options. One is acid hydrolysis, you will get this, and second option, partial hydrolysis, very important, partial hydrolysis, you will get this. When you get NH2, you instantly keep it in your mind this, nitrous acid, and this part becomes this. And one more thing, when you get isocyanide on reduction, you will get second degree amine. You just keep it in your mind. I have done in my previous class. And when you get OH, you treat it with this, you will get I, then and then you treat it with this one, and option I will explain what the option left out with you. You will get Cn. So 1, 2, 3, 4 and 5. Another one, when you get CONH2, you have two options. Either you reduce it or you do Hofmann degradation. This vanishes. And if you reduce it, that CO group will become CH2NH2. CO group becomes CH2NH2. So keep it in your mind that when you get this, you try with this. Whenever you get this one, you try either of these two. When you get COOH, you try with this ammonia, and when you get CONH2, you try both. And which one will be your appropriate or desired result? It depends upon the demand of the question. I will tell. When you get CN, you attempt two things. One, acid hydrolysis COOH or partial hydrolysis CONH2. When you get CONH2, you try with this one. When you get NC, you will get 2 degree amine. Let us take example 1, 2, 3, 4, 5 ticks. Within a minutes, we will solve each one. First one from your text, ethanoic to methanamine. I told you to just follow me. When there is COOH, you try with this. This is my concept. And second concept was, when you get this, you try with Hofmann degradation, or you reduce it, CO will become CH2NH2. Two things, and which one will be appropriate, that depends upon the demand of the question. Now, in our question, it is acetic acid. So let us try unknowingly with ammonia. So you are getting, I start with this COOH group, today's first part, and on hitting, water molecule goes out, you are getting. So when you get this one, my option is either you try with Br2COOH Hofmann degradation, bromamide degradation, or you reduce it to CH2C. When you will reduce this one, which one you will take path? Which path will be the appropriate path? That depends upon the demand of the question. You see, there is ethanoic acid or acetic acid, and you are saying methylamine. One carbon is less. Your chain is decreasing. So on reduction, chain increases. So it becomes CH2. Carbon is introducing, chain increases. But here we are getting one carbon less. So one carbon less is Hofmann degradation. So you do bromine and potassium hydroxide. That part vanishes. You are getting this. Your desired result is this. So you will find the each and every one is very easy. Just to follow. Next one is hexanitrile 2 pentane 1 amine. So this is nitrile. So again you go to my concept. What I told you, when there is CN, you acid hydrolyzed or partial degradation. So first of all, you hydrolyze it. So what you get is COOH. Again we have to treat with ammonia to get. You can do it in another way also. Then when COOH is there, you treat with COOH is there, you treat with ammonia, you will get amide. Then with amide you try to with this one. Okay, but you will get directly amine in the first one. I told you when it is hydrolyzed, and when it is hydrolyzed you will get COOH. CN becomes COOH. When it is partially hydrolyzed, in one step we will get partially hydrolyzed. In first step we will get amide. When amide is there, very simple. When amide is there, pent, hex, one is less. So COOH2 Br to CH becomes only NH2. If it is Hofmann degradation reaction with bromine and this, just will follow the second part, first one. So that will vanish. Pentane 1 amine. Third one, within a very short time you will get the answer. To ethanoic acid. Methanol to ethanoic acid. Am I right? This is conversion. So you recall what I told. When OH is there, a bit earlier I told you, when OH is there, you try to treat with this, make it halide, and then calcium made with cyanide. Then you follow cyanide when cyanide is there, partial or acid hydrolyzed. So as per rule, what will you do here is so when CN is there, we will acid hydrolyze it. I have written here. So on acid hydrolysis, what you get here is CH3 COOH. Is it not our desired return? Methanol to ethanoic acid. Very simple. The first, the reaction path I have shown you for amusement, for fun, or for play, or for your happiness, for enjoyment of chemistry. I have done the things which are all from the concept, and these things in comparison to the first road mapping one, a huge one, it is nothing but a small grain. Now, what was third one? CH3, CH2, NH2, to CH3, and see, I told you at the very beginning, when NH2 is there, you try with NH2. That becomes alcohol, it is known to you all. When NH2 is there, NH, amine group is there, nitrous acid reaction, it makes alcohol. So first happen CH3, CH2, NH2, you give nitrous acid, you are getting CH3, CH2, OH, make oxidation, CH3, that part become CHO, on further oxidation, that part become CW. It is known to you all, you all know. So when COOH is there, again I have, at the very beginning I told you I have effaced it out, ammonia. Again you are getting CH3, NH4, on release of water, heating, CH3, CO, NH2. You see, each and every one follows the rule. Are you not getting amide? And one thing, there is carbon, one carbon, two carbon, and there is one carbon, less carbon. So degradation will follow. Yeah, one is degradation, other is increase in chain. First one is degradation, means decrease in chain, number of carbon is less, and in second case number of carbon is increased. So here carbon is less, so you should follow Hoffman bromide reaction, so that your this part vanishes, you are getting CH3, NH2. You see, each and every one is under your control. You just follow the 5 rule, you can solve out each and every one. And I never think that if you just follow the reaction over and over, do the reaction over and over again, you can keep it in your mind, you can do it correctly in exam. I never think so. I always stick to the point that if you know the concept, if you know the rule, if you know the, have the idea, you can solve out yourself simply by sitting in exam hall. Otherwise you can't. In any steps there is any problem, you can't solve out yourself. You will be confused in the exam hall. Next, third one is methenamine to ethanamine. CH3, NH2 to CH3, CH2, NH2. So am I right? Methyl acid. Ethanoic acid to propanoic acid, CH3, COOH. Ethanoic acid, yes. So here increase in the chain, ethane to propane, you make it reduction increases. Then CO group becomes CH2. It is rule, you have done it earlier, and it is alcohol. When it is alcohol, you T2, PN, I2, CH3, CH2, I, with KCl, you are getting CH3, CH2, CN, then on hydrolysis, you are getting CH3, CH2, COOH. You have done it on hydrolysis, that becomes yes. Next, oh, next one is nitromethane to methyl dimethylamine. Nitromethane to dimethylamine. So what is nitromethane? This is nitromethane and it is dimethylamine. A bit earlier I have told you, I have effaced it out I think, when it is NC, not CN, and if you reduce, then you will get 2 dBm. You will get 2 dBm. You just follow this one. You just follow this one. So when nitro group is there, at the very first, I told you, when nitro is there, at the very first place, you make it reduced. You reduce it. Otherwise, you can't proceed. Nitro, the reduction of nitro, on reduction of nitro, that NO2 group will become amine. Am I right? Amine. Here is, you have to think a bit, because I need 2 dB amine. I need 2 dB amine. So when 2 dB amine, to get 2 dB amine, I need NC. I need NC. This one, this group. So NC group is carbylamine test. Primary amine 1 degree, aromatic or aliphatic primary amine on treating with chloroform and potassium hydroxide gives carbylamine reaction. So you write better CaCl3 potassium hydroxide. This is carbylamine, means NH2 become NC. Fishy smell, foul fishy smell. And reduction, that will give 2 dB amine. You are getting this, on reduction of this, you are getting 2 dB amine. Just a bit think is needed here. You need to get carbylamine reaction and to get NC group, and when you get NC on reduction in this, you are getting 2 dB amine. This is your desired result. Next one is nitrobenzene to benzoic acid. Within a fraction of second you can do nitrobenzene to benzoic acid. Nitrobenzene, you reduce it. Nitron reduction, you know, FeHCl or TnHCl. You can write it. So that becomes amine. And over and again, I need not tell you, when NH2 is there, you treat it with nitrous acid, benzene diazoxide chloride, and copper cyanide. You are getting cyanobenzene, and CN I have rubbed it on acid hydrolysis. I have written it earlier. You are getting. So you see, conversion is in your hand. You yourself can do. Next is benzene to metabromophenol. Next one is benzene to meta position. So every thinking is needed here. You see, when benzene, you are getting two things, OH and Br. First OH and Br. So how Br has introduced here? It is electrophilic substitution, no doubt. So what will you do? Here we will treat benzene with HNO3 H2SO4 nitrating mixture, you know it earlier. You are getting nitrogen, and it is in first year you have known that it is deactivating group, NO group, COOH group. These are deactivating CN group. These are deactivating group, and these are meta-directing. They direct the incoming electrophile in meta position. So it is bromine, aluminum bromide will take one bromine here, LBr4, and bromine will be electrophile, and that electrophile will enter in this position. In which position it enters, it will be dictated by NO2 group, and NO2 group is, out of this you are getting electrophile Br, and this Br will enter this position, that position. It will depend upon this group. It is meta-directing group. So your bromine will enter in meta position. Meta. So now our demand of the question is that we need here OH. So at the very beginning I told you, when NO2 group is there, your first duty is to reduce it in NH2 group, and then you see what happens. So as per rule, we are reducing it by this or 10 HCl, and NO2 group become NH2. Am I right? Now, since it is OH, we are not getting OH here, we are getting NH2. So, you know, when we get NH2, we should treat it with HNO2. I have written it earlier. I have done once earlier many times. So, your product is now as per the demand of the question. Am I right? You see what beautiful the organic chemistry is or conversion is if you have the thorough knowledge. Benzoic acid to Amine. So you are layman, you don't know what I told you earlier, that whenever there is COOH, you try with ammonia. Am I right? I start phthalic acid, start with first one phthalic acid COOH and start phthalic acid with ammonia. I know it's very important one, very often it's come in NEET in conversion. So on heating, water molecule leaves out, you are getting benzamide. We need NH2 in place of CONH2. Once again, earlier I told you, a bit earlier, if CONH2 is, you have got two options. Either you reduce it, then CaO will become CH2, or you make it Hofmann degradation, bromamide degradation reaction if you want to reduce CO. Right? So here there is no CO, so we will blindly go for. You see, you are strict following the rule what I mentioned at the very beginning. So you will find everything very easy. So next one, and if you want to learn by heart or on practicing, you can solve it. I never think so it is so easy. Aniline 2,2,4,6 tribromo fluorobenzene. Let us see, we may not have any idea, just we see what we can. This is aniline and this is 2,4,6 tribromofluorobenzene. No idea what we can do. So when NH2 is there, we will treat with HNO2. That was my first idea I gave you. First of all, you see, when bromine is there, you do. It was in the previous class I have shown you. When there is bromine water in aqueous, bromine in aqueous, bromine water, then and bromine enters in 2,4,6 position. Am I right? Now our target is that there is fluorine, there is no NH2. So when NH2 is there, we will treat with, as per rule I have mentioned a bit earlier, we will make it benzene diazonium chloride, and you have fluoroboric acid and heat. What you get is this. If you have followed my class or gone through my class, it will not, this part will be very easy, because it is Bulge-Seemann reaction. I have done it earlier. So you please go through each and every class. If you can understand, you can follow the organic chemistry, you can do the organic chemistry smoothly, and if you have a strong hand in organic chemistry, please you follow yourself, it will be better for you. Otherwise skipping the classes, and if you just follow middle class, third class, fourth class, and this I will see it later on fifth class, you can't understand anything. For your clear understanding or betterment in entrance exams or board exam, you just follow the rule. All my classes, ultimately you will be very expert in organic chemistry. It's my assurance. You just follow the class without skipping the class. Don't skip the class. Next one is benzyl chloride to 2-phenyl ethanamine. Benzyl chloride to, what was the question? Benzyl chloride to 2-phenyl ethanamine. This is phenyl. 2-phenyl, meet it, ethanamine, benzoyl. I think in my fourth class I have told this, how you name it, is benzyl chloride. So benzyl chloride to 2-phenyl ethanamine. Benzyl chloride to phenyl ethanamine. So what we can do here is halide. I have told you, when alcohol is there, made it halide, then with cation. Am I right? Just you follow the rule. So there is no OH, there is halide group already is there. So you treat with cation. Am I right? Just follow the rule which I have written in the right. So your answer will be one step left. Step left. Just you see the beauty of chemistry. Here it is amine. When you get CN, either that CN, I have rubbed it, you can oxidize it, you can reduce it, or acid hydrolyze it. When you will acid hydrolyze, you will get COOH, and on Hofmann degradation you will reduce it. Number of carbon chain will decrease, but here chain increases. Am I right? So no way left, you reduce it. So on reduction, what's happened? On reduction, what's happened here is Cn becomes CH2NH2. I have rubbed it off. On reduction, one CH2 group increases. So this is nothing but 2-phenyl ethane amine. 2-phenyl ethane amine. So next one is chlorobenzene to parachloroaniline. Chlorobenzene to parachloroaniline. What we do here is very simple. C is activating group, orthene para directing, para is major. So first we will introduce HNO3, H2SO4. Very often you are getting this one is nitrogen mixture. You are getting NO2 group. NO2 group is electrophile, and this is a director. It will direct the NO2 group in orthene para position. Para is the major. So you are getting nitro group in para position as major. But we need NH2. So at the very beginning I told you when NO2 is there, you reduce it, you get amine. So you tin or reduce it with any reducing agent, you will get it Cl NH2. Our desired product is this. Next one is benzamide to toluene. I have done it in the very beginning. I have done each and every one is there at the very beginning. I have given you a road mapping one. Benzamide CONH2 to toluene. If you think of it, you can't do anything. So first of all, there is no similarity out of these two. You can't proceed anything. You do as per rule what I told. If CONH2 is there, at the very beginning I told you, you either reduce it. If you reduce, that CO becomes CH2NH2, chain will increase. Or if you do Hoffman degradation reaction, that group vanishes. You are getting a compound having less number of carbon. And a bit earlier I have told, when NH2 is there, you treat it with HNO2. Please follow the rule. Automatically you will find the answer. When this is the orthophosphoric acid, am I right? At the previous class I told it gives you benzene, when benzene is there, Friedel cup alkylation, this will take out this. This group will come here. Sorry, I am showing you AlCl3 CH3Cl plus AlCl3. You all know it is Lewis acid, deficient of electron, and that group get attached with this one. So you are getting this S plus, and AlCl3 is unstable one. This is electrophile, and that electrophile will enter by substitution reaction. This is toluene. And you can say what happens with this one. This methyl group is substituted with the replacement of one hydrogen from benzene ring, and that hydrogen is react with this one. So again you get in the reaction mixture same things. Am I right? This is all about the today's lecture. Thanks a lot for being in the class from first to last.